So let's dive into the substantive portion of our conversation today. And for this, let me start with a question, and that is, what is AI ethics? And it turns out that this question is very hard to answer, and this difficulty is quite telling. In fact, both components of this term, AI and ethics, are difficult to define and are intimidating, right, as concepts. And the interplay between them is also very difficult to speak about. But we will try nonetheless. So I will use the term ethics to denote the study of what is morally good or bad, and morally right or wrong. AI ethics then refers to the embedding of moral values and principles into the design, development, and use of AI systems. And much of this conversation, as we will see throughout this 45 minutes or so, centers on the unintended consequences of AI. The next question is, what is AI? And no universally agreed upon definition of AI exists today, unfortunately. But, as an academic and a technical person, I do want to come up with a definition. So I will propose that we use this definition on the slide for the purpose of our conversation today. So I'd like for us to think of AI as a system in which algorithms use data to make decisions on our behalf or help us, humans, make decisions. Note my emphasis on the system view rather than an explicit focus on algorithms alone. An algorithm on its own does not constitute AI. You also need data and you need decisions and a context of use. When discussing AI, we usually make a distinction between systems that operate according to predetermined rules, such as Roomba, the smart vacuum, and those that learn rules from data. And here I'm giving examples of a chess-playing AI, a self-driving car, and an algorithmic hiring system on the bottom right. The distinction between rule-based and learning AI systems is not strict. As most of you probably know, modern AI systems use and combine rules that are given ahead of time with some form of learning. So now let me give the punchline of today's talk. And then we will elaborate on this punchline. So if you doze off, please just remember up to here. To give this punchline, I'd like to use a quote from a book that I like very much called The Age of Algorithms, that was written by Serge Abitboul and Gilles Dovec. Algorithms are probably the most sophisticated tools that people have had at their disposal since the beginnings of human history. They have transformed science, industry, and society. They upset the concepts of work, property, government, private life, even humanity. Going easily from one extreme to the other, we rejoice that they make life easier for us, but fear that they will enslave us. Slightly paraphrasing from the book, algorithms, creations of the human spirit, algorithms and AI are what we make them, and they will be what we want them to be. It's up to us to choose the world we want to live in. And I hope that this point of view resonates with the engineers in the room. And I am one of them, right? We don't just take life as it comes at us. We want to change it. We make to change the world. We want to make things better for ourselves and for others around us. And technology presents us with this opportunity. So now I will tell you more to expand on this punchline. So far I told you, and I gave you a definition of AI, and I also gave an interpretation of AI ethics. Now, what about responsible AI? This is the actual title of my presentation today. It is customary to use this term to include AI ethics, as well as some other concerns like legal compliance and reproducibility and environmental sustainability and safety. Zooming out from this list, I like to use the term responsible AI to refer to making the design, development, and use of AI socially sustainable, using AI for good while controlling the risks. Why are we focusing on responsible AI so much today? It's really not a new concern, right? The reason that we focus on this and that we worry is because AI has been so very successful. and very often surprisingly so. So we can no longer shy away from this conversation. Now, there is, of course, no question about the positive impacts that AI has had in our lives. I'm giving here some examples where AI is being used successfully, where AI systems work. We have AI-powered vacuum cleaners. We know they work because they leave the room clean. We have AI-powered game systems. We know that they work because, in the example of the chess-playing AI, they beat Garry Kasparov, the legendary grandmaster, at his game. And we also have all manner of smart home devices. I'm showing a smart light here at the top left of the slide. We know that these systems work because they lower the energy bill and they save us the need to get up from the couch to turn off the light. These systems are by no means easy to make. It took us decades to come to a point where we can get systems like this that work. But at this point, we know how to make them. And importantly, we know how to check whether they work. These systems are all responding to a particular clear need for improvement on the status quo. We are technically ready in terms of data, software, and hardware to make them, and we can validate them. These are some of the hallmarks of responsible AI, as I am summarizing on this slide. Next, let me give you a couple of examples, or rather one prominent example from the medical domain, medical imaging, where, like in many other domains, AI is all the rage. Cutting-edge AI tools are starting to be used in clinical practice to improve medical diagnosis and prognosis capabilities. As one example that I'm highlighting here, a recent study done by a team of researchers from the NYU Medical School and Facebook AI, and I like that this is Facebook because I beat up on Facebook quite a bit in my talks, but no system, no government, no company is homogeneously bad or good, right? So this is one of the really excellent things that Facebook AI, now Meta AI, has contributed to. So the system that I'm discussing here is called Fast MRI. What is Fast MRI? It's when you take MRI scans that are done very, very quickly, 10 times faster than you would normally need for a full MRI scan, and you augment them with the help of AI with some semi-synthetic data. And the result of this is a semi-synthetic scan that is diagnostically interchangeable from a full traditional MRI. And as I said, these scans can be done much, much faster, about 10 times faster than a regular MRI would take. And they require 4 times less data. And this can make the difference between getting an MRI and not getting one for a claustrophobic patient. And it can also increase the throughput, the number of patients that you can see, that you can diagnose with the help of a machine, where these machines are in limited supply. And so here, of course, there are going to be cases where when people use these semi-synthetic scans, they will misdiagnose a patient. So these systems and the predictions based on these scans can fail. So to put them into safe use, we must have another factor that contributes to responsible AI, and that is decision maker readiness. A clinician is assisted by an AI, but they understand that they are ultimately responsible for the diagnosis and treatment. They know when to trust AI predictions and when to challenge them. As another example along similar lines, we are seeing breakthroughs in automatic diagnosis of lung and breast cancer, where AI is performing comparably to the best human pathologists. But most importantly, where human AI teams outperform both humans alone and AI alone. So this is really what we want to see in this domain. Now, having seen these successful examples, we may be tempted to try using AI to solve some other pressing problems. So let's take hiring as an example. And this is a domain in which I have been very, very active in policy, among other things. So taking hiring as an example, humans are notoriously bad at hiring. We are really biased. So here I'm highlighting the persistent problem of bias in hiring, which exhibited itself, of course, already in the analog days. So this is from 2004, a result published by Marianne Bertrand and Sindil Mulainathan, who sent fictitious resumes to help wanted ads in Boston and Chicago newspapers. To manipulate perceived gender and race, they would randomly assign African American versus white sounding names and men's versus women's names to the same resume. And then they would send these out by fax or by mail and wait for callbacks. And what they found was that white names received 50% more callbacks on the very same resumes. So the question is, and the jury is still out on this, is whether AI can help us address this really difficult problem. Do you think it can? Let me see. Maybe, yeah, okay. So unfortunately, so far, what we've been seeing is that results are not so great. So on this slide, I'm highlighting results of a well-known 2015 study out of Carnegie Mellon that showed that Google displays ads for high-paying jobs significantly more frequently to men than to women, all else being exactly equal, because these were not real men and women. These were actually synthetic profiles of web users that were the same in every respect except for their binary stated gender. Another failure of AI to counteract gender bias in hiring is highlighted on this slide. This is a 2018 example of Amazon having developed an AI-based resume screener with the stated goal of increasing workforce diversity, but the AI taught itself the opposite thing. So it taught itself to be gender biased, penalizing resumes that included the word women's, as in women's chess club captain, and downgrading resumes from folks who went to some all-women's colleges in the US. And what's interesting here is that this is Amazon. They wanted to do the right thing. They have unlimited resources, human resources, capital, compute, tech, right? And still they were unable to address this issue of gender bias in hiring with the help of a purely technical solution. The next example, where we go from not so great to outright awful, is Latanya Sweeney's experiment that she conducted in 2012, 2013, where she showed evidence of racism in Google's online ad delivery. She is a computer science professor at Harvard, Latanya Sweeney. And as you can see by the picture, and also guessing by her name, she's African American. The story goes that she Googled her name when she was speaking to a reporter, and she was shown an ad from this company called Instant Checkmate asking whether she wants to see Latanya Sweeney's criminal history. She knows that she does not have a criminal record, and of course she had a hunch that this ad was shown to her because her name sounds African American. And then she designed the systematic study and was in fact able to show that ads indicative of a criminal record are being shown very significantly more frequently when you Google with African American sounding names versus white names, even if you control for whether somebody has a criminal record. And this is awful generally, and specifically also, of course, relates to hiring, because before you're hired, people are going to Google your name as part of an informal background check, right? And so when they see this ad, they're probably just going to move on to the next candidate without even clicking, right? So in summary, AI rarely helps reduce bias in hiring from what we've seen so far. And to make things even worse, more often than not, hiring managers are not given enough information about the tools that they use in the hiring process. And they don't have enough of an understanding about these tools, how well they work, are they biased or not, to be able to contest their predictions and decisions. And they are under very heavy pressure to deliver very quickly, right? So there actually isn't an organizational incentive for people to be questioning the output of these tools. So using my hallmarks of responsible AI, unfortunately here, technical readiness lacks, the tools don't work. The means for rigorous evaluation lack. You don't know how people would have done whom you didn't hire. And decision maker readiness and organizational readiness lacks as well. So as another example, let me return to the medical domain. In their 2019 paper published in Science, Obermeyer and co-authors studied a risk assessment AI that affects millions of patients in the United States. This AI is a decision support tool. It assigns a risk score to a patient, and patients with higher risk scores are given priority for access to medical resources. The authors of this article found strong evidence of racial bias. At a given risk score, Black patients were considerably more sick than the white patients. So a 6 for a white person and a 6 over risk score for an African American mean different things, as validated by external clinical evidence. Now I'm going to quote from the study. The bias arises because the algorithm predicts healthcare costs rather than illness. But unequal access to care means that we spend less money caring for Black patients rather than for white patients. End quote. Biased predictions reinforce and amplify this inequality. I find this example really insightful, in part because it shows that if we get to the bottom of the issue, then we can attempt to mitigate these risks. In this case, mitigation would involve getting better data, selecting better validation metrics, and even building 2 separate risk assessment tools, which is warranted in the healthcare domain. You can actually do this. One that would be used for African American patients, and another that's used for patients of other ethnic and racial groups. But in other cases, risk mitigation may require that we discontinue the use of a specific tool or give up on the idea of using AI altogether, because we cannot build a tool that works. Generally, though, the negative examples I listed are much more difficult to summarize than the positive ones. And this, to me, as an educator, is not surprising, because usually there are only a few ways to get things right, and there are very many ways to get things wrong, right? So when you grade students' exams, you see how many wrong solutions there are, and already this variety kind of exemplifies this phenomenon. So next up, I'll give an example of morally questionable use of AI. This example concerns the use of AI in the criminal justice system. And many of you, I think, are familiar with the story that came out in 2016 and was covered by the press extensively. This is an investigation by ProPublica of a commercial tool that was called Compass at the time, that predicts whether a criminal justice involved individual is likely to commit a crime in the future. The predictions were shown to be racially biased, incorrectly deeming African Americans more likely to recidivate compared to whites, meaning they had higher false positive rates, and conversely for false negative rates. Now, importantly, this tool was predicting whether somebody will commit a crime in the future based on how others like them behaved, right? So this is why I'm saying that this is morally questionable. And irrespective of the kinds of mistakes that these tools make, we must question whether the use of such tools is something we're okay with in society. Is it acceptable to predict whether someone will commit a crime in the future in general, and whether it's acceptable to predict this based on how others acted? This reminds me of this 2002 movie called Minority Report. My students haven't seen it. I've been teaching a class called Responsible Data Science, and for 5 years I've been teaching it. The first year, most students have seen it. Now this year, they don't know it. But it's still a very relevant movie, right? And I mean, it really applies directly to this. I personally don't think that we should be using predictive analytics in the criminal justice system, and this is why I, as an engineer, don't engage in work in that domain. Because I think that if I, as an engineer, engage, that means that I see a role that AI can play in that domain. I do engage in the hiring domain. I think there is something to do there potentially, but criminal justice for me is out of scope, and I say this openly. So the final example I'll give is when the use of AI is simply nonsensical, and this is based on our own work, my work with collaborators. We looked at AI-assisted personality prediction. I will use the priceless air quotes here, in hiring. So we bought subscriptions to 2 tools called Humantic AI and Crystal. And these tools claim to be able to tell how dominant, steady, agreeable, etc. an individual is based on their resume or their LinkedIn profile or their Twitter handle. And then these predictions, these personality profiles, are used by hiring managers to match people with jobs. Now, rather than directly contesting whether personality is a valid construct, we instead audited the assumptions made by the vendors of these tools themselves, namely that the tool will produce the same or very similar personality profile output if the input, for example, a resume, changes only slightly or does not change at all. And if it does change, then the way in which it changes should clearly not impact the prediction, right? So if you think about tests that you do on pen and paper, it shouldn't matter whether you write with a black pen or a blue pen. The result of the test should be the same, right? And it shouldn't matter if you do it on the computer or you do it with pen and paper, the test should work. Now, what we found was that unfortunately, this is not the case, that these tools showed instability, as we say, on key facets of measurement. So for example, we found that a person may be considered more or less dominant and more or less steady if they send in their resume in a different file format, PDF versus raw text. And the tool doesn't tell you which format it prefers. It does not prefer either. It says, give me your resume in PDF or in raw text. And it doesn't help you to always submit it in PDF. Sometimes you're more dominant, other times you're less dominant. So that's why I'm saying that this is nonsensical. Happy to discuss offline. Now, let's try to make sense of these examples, especially the negative ones, where things have gone wrong for a number of reasons, from mistakes to morally questionable use of AI, like in criminal sentencing, to outright nonsense. Let's talk about these mistakes. So here's an example. A customer service AI at your favorite online shoe store may misunderstand your order and the wrong pair of shoes is shipped to you. And this is very annoying, but the consequences of this mistake are not severe and they are reversible. You send back the shoes, you get your money back. Let's return to our easy example here, a smart light AI. It too can make mistakes. It may incorrectly guess whether the light should be on or off in your house. Turning on the light in the middle of the night will wake you up, and leaving it on systematically when it should be off instead will leave you to foot a high energy bill. We already discussed AI in hiring. When hiring AI makes mistakes, and especially when these mistakes are systematic, then consequences will be felt by individuals, population groups, and society at large. So it's a death by 1,000 cuts. These are small individual harms that are cumulative and harmful when we take them together. Now, further, of course, there are cases where mistakes, even single individual mistakes, can lead to catastrophic, irreversible harms, even to the loss of human life. The most striking of these, pardon the pun, is the example of an autonomous car that miscalculates the trajectory of a person on a bicycle or a pedestrian in a wheelchair. Let's say it enters the intersection, it hits them, and the person dies or is severely injured. And this would happen because the AI inside the car's control system does not recognize the person as one of the types of objects that it expects to see on the road. So let's dwell on this last example a bit. We all know that human drivers also cause accidents. So why let the perfect be the enemy of the good? Shouldn't we be prepared to suffer a few mistakes made by autonomous cars in the name of increased overall safety of our transportation system and in the name of the convenience to the drivers? In fact, can't we just encode our judgment about what mistakes are more important to avoid and let an AI sort out the trade-offs? To rephrase, can we equip AI with our values? This line of reasoning opens a can of worms depicted on the left of the slide. And this can of worms has a name. Its name is algorithmic morality. So what is algorithmic morality? It's the act of attributing moral reasoning to algorithms. It's grounded in a simple and attractive doctrine of moral philosophy called utilitarianism. One of the fathers of this doctrine, Jeremy Bentham, whom I'm showing on this slide, famously said, "It is the greatest happiness of the greatest number that is the measure of right and wrong." Now, this sounds great indeed. Unfortunately, things are not as simple. To start, how do we measure happiness and unhappiness? And how do we then encode these measurements into a set of objectives that an AI can understand? Contrary to what you may hear in the press these days. This is still a fact, right? An algorithm is a sequence of commands. So here I will take a leap and assert that to build AI systems responsibly, we must think about what values are baked into these systems, who benefits when the systems work well, and who is harmed by their mistakes. And we must collectively take responsibility for deciding on the balance between the benefits and the harms, so that the greatest happiness that Jeremy Bentham promises to the greatest number is also enjoyed by the greatest diversity of stakeholders. And this work of collectively understanding and negotiating the trade-offs is what roots the design of technology, AI in particular, in people. Now, as we design and use AI systems, we should keep the following questions in mind. What are the goals of the system? Who benefits when the system works well? What are the actual or potential of the system, and to whom are these the harms? Who is harmed? And finally, who is in a position to do something about this? Who is in a position to mitigate? Now, where do we go from here? As a technologist and an engineer, I'd like to understand how I can help bring AI systems under control. Can we build technology that helps us implement ethical norms and legal compliance? And to think about this formally, let's focus on one aspect of this. It's a very large space, as you already are seeing, and this aspect is going to be bias in AI. So for this, I'd like to recall a classic. In their seminal 1996 paper, Batya Friedman and Helen Nissenbaum identified 3 types of bias that can arise in computer systems. And I'm showing them here jointly with the help of a 3-headed dragon. And each head is labeled with the bias type, and these are pre-existing, technical, and emergent. Pre-existing bias is independent of a technical system. It has its origins in society. Technical bias is introduced or exacerbated, made worse, by the operation of a technical system. I'm using here the keyword ADS. This means automated decision system. So sometimes we use that interchangeably with AI. And finally, emergent bias arises in the context of use of a system, because recommendations made by these systems, they impact the world, and they create feedback loops that then feed back into the technical system through data. So let's start with a discussion of pre-existing bias. To think about this kind of bias, I like to use the following metaphor. Data is an image of the world. It's mirror reflection. And when we think about bias in the data, pre-existing bias, we interrogate this reflection. One interpretation of bias in the data is that the reflection is distorted, that we mismeasure the world in the data that we collect. Another interpretation of bias in the data is that even if we were able to take a perfectly accurate picture of the world in a data set, it would still be a reflection of the world such as it is today, and not a world that could or should be. Now, a couple of points based on this. First, it's important to keep in mind that a reflection cannot know whether it's distorted. That is, data alone cannot tell us whether it's a perfect reflection of a distorted world, or a distorted reflection of a perfect world, or if these effects compound. The assumed or externally verified nature of these distortions has to be stated explicitly by a human and used as input to technical interventions, like data debiasing that you may have heard of. The second point is that it's also not up to algorithms or data to tell us what the world should look like. This work is for us, people, to do, right? It's up to individuals, groups, and society at large to come to consensus about whether we are okay with the world such as it is today, or if we should change it in some way, and if so, how we should change it. And this is the very, very difficult work of democracy that data and AI has now entered. And so this once again limits what we can expect of purely technical interventions, like Amazon's resume screening AI, right? Here are a couple of examples of pre-existing bias or bias in the data, just to illustrate that the data only tells us so much. On the right, we see evidence of underrepresentation of women in the workforce. And this was used in an article that described that failure of Amazon's resume screener, because it was demoting women, right? It said there are few women in the workforce, and this is what the algorithm learned. On the left, we see evidence of tests, standardized tests, the SAT in this case, being miscalibrated, or of differences in access to educational opportunity that are exhibiting themselves in these differences of score distribution by ethnicity. So on the far left, you can see the score distribution on the math SAT test for Asian students. Green is better, and you see that there are more students who have high green scores. And on the far right of that part, we have black students who have very few scores that are in the green, right? This is what the data says. Why this is, the data can't tell us. We have to assume, we have to state that this is because people of different ethnic groups have had different opportunities for access to educational resources, right? And this is an assumption you can make. And then once you make an assumption and you state it, then you can enact an intervention, if you so choose. My third and final point is that changing the reflection, changing the data, does not necessarily change the world. If the reflection itself is used to make important decisions, for example, whom to admit to a school or whom to hire, then compensating for these distortions in the data at that decision point is worthwhile. But the mirror metaphor only takes us so far. We have to work much harder, usually going far beyond technical solutions, to propagate the changes back into the world, not merely brush up the reflection. So this I'm just going to flash past you here. This is a survey article that I wrote together with a couple of former students, where we speak about fairness in set selection and ranking. These are technical gadgets that I've been working on for many, many years, where we talk about what are the assumptions that we should make when trying to make these methods more fair, and then how do we enact our interventions under those assumptions. Happy to discuss if it's of interest to you. How much time do I have? Is it 5 minutes?
10.
10? Okay, perfect. So now let me switch gears a little bit and talk about technical bias, right? This is the second head of our dragon there. And this, in fact, is the kind of bias where we technologists have the most to say. This type of bias arises due to the operation of the technical system itself. And it can amplify pre-existing bias, or it can introduce new bias. And the reason that I, as a technologist, like to think about this is because this is less controversial than pre-existing bias. There, something happens in the world, we can try to make assumptions and maybe fix things a little bit, but they're not going to take us all the way. Here, it's we break it, we fix it. So it's a much simpler sort of an environment for an engineer to operate in. So let me give a concrete example here of how technical bias may arise in a typical data science pipeline, and how we can attempt to mitigate it. So here we will consider Anne. She's a data scientist in the human resources division at a large retailer. And Anne was asked to develop a model, a data pipeline, and then a model that predicts the level of compensation, the salary, to offer to somebody whom the retailer wants to hire. So what is the competitive salary to offer to them that they will be likely to accept, and that's not too high. Anne is going to start by taking in demographic and employment history information from job applicants, and both of these are self-reported. Following her company's best practices, she is going to split her data into training, validation, and test, will implement data pre-processing, such as combining or joining this data from the two input tables, and importantly, interpolating missing values. This is what we will talk about the most. And after that, she's going to do model selection, training, and tuning and validation. And then she'll look at how well her predictor is working. This is a supervised learning scenario, so she knows what salary would have been appropriate for everybody. And she notices a disparity. The accuracy of the model is lower for women than for men. And most mistakes for women are such that the model offers a lower salary for them than they would want to get on an offer. And furthermore, she is seeing that this is happening most strongly for people who are relatively older, so middle-aged women and also some middle-aged men. Now, Anne is asking what should she do about this? How can she debug this issue, right? It's a complex pipeline, so what should she look at? Thankfully, based in part on her own lived experience, she has a hunch. Anne goes back to data pre-processing and observes that the value of a feature called the number of years of experience was missing far more frequently for women than for men. And then she looks at the employment histories, at the demographics of these individuals. She sees when they graduated from college, and she deduces that for many of them, they are older, right? So people who are older are not disclosing how many years of experience they have. Why would this be the case? Any thoughts? Age discrimination, right? So people, in fact, who are older are not incentivized to tell you when they graduated from college, for example, right? But then what does that lead to in our predictor? All else being equal, the more experience you have, the more money you should be offering, right? So then these people are being underestimated by the system because this value, when it's missing, is being imputed by taking the default method in, let's say, scikit-learn, which is to take the mean of the population, right? So of the people who said how many years of experience they have, we take the mean, and this is what we use to fill in the values. Now, why is this a problem? So let me just show you kind of what that does to the distribution, right? So here we have some missing age values. Here's how my mean imputation imputes, and this is the reality. So you see that the mean actually is shifted to the right, right? So by shifting it left, you're gonna think that people are younger, you will offer less money to them. Now, if Anne realizes that this is happening, she will understand that the assumption that she was making by taking the default imputation method, which was replaced with the mean, was incorrect because values were not missing at random, as we say. Meaning whether or not a value is missing is not independent of what the value is. It's more likely that you'll be missing from the right side of the distribution, right? Based on what we just discussed. And we would know this because we live in this world. We know there is age-based discrimination. Anne may know this, right? So this is this lived experience, the importance of the lived experience. And what is the emergent bias that would arise if this were not corrected? People would consistently be offered lower salaries. I told you that many of them are women. And so we would be reinforcing also as part of this the gender wage gap. So this is problematic, right? But like I said, we break it, we fix it. That's the beauty here. Now Anne realizes that this is happening. She can actually come up quite simply with a better, more sophisticated, more appropriate methods to impute missing values. She can impute by demographic group. She can impute separately for men and for women. She can do something that is more sophisticated yet to try and actually extract information from people's employment histories, how many years of experience they should have had, and impute in that way. Now, this is one example of when problems with data manipulation can lead to unintended consequences with accuracy, with fairness, and also long-term effects. There are others of this kind, right? So what we talked about is that values were assumed to be missing at random, but they were not. Other issues can arise when, for example, you're trying to impute membership in categorical groups like ethnicities. And we always would impute membership in either the most frequent group, or we would impute in such a way as to condition on the probabilities of the groups. And so we would never impute somebody to be Native American, right? And this would distort proportions. And it will make it more difficult for our machines to learn appropriately for these smaller groups. What if we just represent our data incorrectly? Suppose we take gender to be binary, but many people identify as non-binary. They are going to select an A or inapplicable or leave that value missing, and then they will be imputed as either a man or a woman, right? Because there is no third category. So this is a trivial example where you should just change your data representation to be able to capture your data more faithfully. There are slightly more kind of less trivial examples here, and this has to do with filtering and with joining, right? So for example, Anne may have taken a subset of her data
to make some testing, debugging easier, maybe she filtered her data to only include particular counties or zip codes. Well, guess what? That's going to impact the age distribution, right? Because geographic location is not independent of age. It would impact the socioeconomic breakdown, the racial breakdown of the data. When you take a join, and here I'm going back to the medical domain, you have patients and healthcare spending. A join constructs a tuple for me, right? A row that includes information from patients and information from healthcare spending. And if you are, for some patients, missing healthcare spending, they'll be dropped from this data. Right? So here again, you're changing proportions. In general, we all, or many of us, know that machine learning pipelines are complex. In the wild, there are very many data pre-processing steps that we treat kind of separately in isolation because otherwise it's too complex. But really, the impact, as I tried to convince you just now, of some seemingly trivial choices, taking the default early on in the pipeline, can have tremendous consequences downstream when your model is trained. So I have collaborated on the development of a tool. This is a research prototype, but for a research prototype, it's really, really robust. The doctoral student who worked on this is a really talented engineer, Stefan Grabberger. So what we created is a data distribution debugger that takes native Python code, and then it parses a graph out of it that allows us to look a little bit more declaratively, so at a higher level of abstraction, at the different manipulations that happen. And then we can semi-automatically instrument this representation of the program to allow the data scientist to track, for example, the use of some attributes that shouldn't be used, or changes in data distributions as a consequence of some operations, and then raise flags. So this is a data distribution debugger in every sense of the word. Let me know if you'd like to play with it. I'm happy to send you to the GitHub repo. It's open source. Right, and I think I'm out of time, more or less, right? So here is a little bit more on another paper where we looked at the impact of data quality or fairness, as in differences in performance for different groups. Underrepresented groups have more missing data very often. You use automated data cleaning, like I just told you, right? It's, for example, mean imputation, and more often than not, that makes it so that your performance degrades for the downstream. And so we did an experiment here with thousands of models to actually show that this happens, sometimes, not always. And so emergent bias, what is that about these 2 minutes? Yeah? It's one where we have fewest answers, honestly, because what we talk about here is what are the consequences of the use of the system that are outside of the system's direct control. So here, the work that I do personally, and that I encourage others to do, has to do with regulation, with how do we keep these systems in check when they are deployed. In New York, we have a law that is coming into effect in July, finally, Local Law 144, that requires bias audits and disclosure to potential job seekers on tools before they apply that will be used to screen them. And this is a law that has been long in the making. It took us several years to push it through. The way that it came together is not ideal for anybody, but as a divorce lawyer will tell you, right, if neither side is happy, then they did a good job. So there was a lot of industry pressure to water it down, a lot of pressure from people like myself to keep it really strong. So we are in some unhappy middle right now, but nonetheless, it's the first law anywhere that I know of that exists and that is going to try to regulate in this space. I wrote about this extensively. This is a Wall Street Journal article that I wrote where I'm arguing for a nutritional label that should accompany a job posting to tell people what they can expect should they apply. And there should also be a label that accompanies a decision ultimately, but this is the posting label still, right? Before you apply, I'm saying you should be able to exercise informed consent. You should actually know how the systems will screen you, and you should be able to decide to not apply if you're not comfortable with that. For example, if they're going to try and construct your personality profile, maybe you don't want to do it, and then there is no option to opt out. But in any case, we need very clearly stated qualifications. We need information about what data about us the system will use. Is it going to go and snoop around my Twitter feed? You know, if so, maybe I don't want to apply for this position. Yeah, so this is something that I feel really passionate about. I hope that this comes together. And to sum up, we talked about AI, algorithms, data, and decisions, and impacts in the real world. Whether or not our systems are responsible depends on all of these components, right? Do we trust the data? Did we collect it in a way that is trustworthy? Is the data we are about to use actually appropriate for use for this particular prediction? These systems depend on algorithms. Have we tested our algorithms? Do they work? According to what measures did we test them? And why are these the right measures? Is it false positive rates or false negative rates that I care about, for example? And why so? Did we use the scientific method to actually test that our AI is doing better than a random coin flip, or a gender biased or a racially biased coin flip? And finally, what are the decisions that we're asking these machines to make on our behalf? And should we be asking them to be making such decisions? Do we have reason to believe that something can in fact predict how somebody will do on the job? That it can in fact predict whether somebody will receive it? And even if we think that it might be able to predict it, is it ethical for us to be asking that? Or does that deny us or the people being impacted agency as humanity? So these are examples we saw already. We need to have a nuanced conversation about these topics, right? It is not, yes, let's use technology for everything, techno-optimism, or no, technology is awful, let's throw it out, techno-bashing. We should be somewhere around the nose of this person, right? Just, let's bring some nuance to the conversation. Let's not be too frightened, because the people who are trying to scare us, the Terminator is coming for us. They are pursuing specific financial goals. So just keep that in mind, right? To whose benefit is it to be telling us that doomsday is right around the corner? And are they doing this because A, they can make money on that narrative, and B, they don't want us to think about the real issues, like who is not getting fired, right? Because that's stupid, and we all are responsible, right? Technology certainly, but we're not the only ones, because we are not everybody. No matter how smart or how well-meaning, we cannot put ourselves simultaneously into everybody's shoes. So we need to talk to people being impacted, to get their opinions, to get their fears. And yeah, so please tell everybody, and including your mother and your grandmother, what you know about AI. Tell them to just, inhale, exhale, and keep calm. And here's some comments in English, and I have them in Spanish as well. Not with me, but yeah, thank you very much.